Welcome to your next lesson. This lesson is on proportions and similar figures. So these are sections 1-4 and 1-5. So as always, we start with the driving question. Today's driving question: when and how should proportions be used to solve real-world problems? So here's the essential understanding. This is taken directly from the textbook. If two ratios are equal and have a quantity in one of the ratios is unknown, you can write and solve a proportion to find the unknown quantity. So just to let you know, these are two ratios. A ratio looks like fractions like these. So those are the ratios. It does show that they are equal because we have our equal sign here. And then it says a quantity in one of the ratios is unknown. So that means, for example, our variable x is unknown. That's what we want to know. So we can write and solve a proportion to find out this unknown quantity. So we are going to solve this problem to figure out what x is. That's all this essential understanding is saying. Now, we're not actually going to solve this specific problem, but we are going to learn how to solve them. There's two different methods, and let's get to that now. So method 1 is called the multiplication property. And we use this method when the unknown variable, so it could be any letter, not just x, is in the numerator of one side only. So when I say that, numerator, in case you don't recall, means it's the top part of your fraction. So here it is in the numerator, and it's only on one side of the equal sign. It's only on the left-hand side. It's nowhere on the right-hand side. It could be on the right, but then it can't be on the left. So it has to be on one side only. So now how we actually solve this. The multiplication property is when we multiply by something on both sides. In this case, I'm going to multiply by 15 on both sides because I want to get rid of that 15 underneath the x. I want to isolate that x variable. So if I multiply by 15 on both sides, I'm left with x on the left-hand side. And on the right-hand side, I have 2 times 15 over 3. Notice that I did not multiply it on top and on bottom, only with the top one. The reason for that is because technically that 15, any whole number, is an invisible fraction over 1. And when we multiply fractions, you multiply the numerators together and the denominators together. So I did the 2 times 15 on top, and technically I did 3 times 1 on bottom, but that makes it stay the 3, so I don't even need to see that 1 in the future. So anyway, 2 times 15 is 30, so that takes me down to the green step. So I have x equals 30 divided by 3, and 30 divided by 3 is 10, so my answer is x equals 10. Now there is technically another way that this could have been done, which is you can reduce as you work through the problem. So maybe right away when you did 2 times 15 divided by 3, you might have seen right here, which I'm circling, well, 15 divided by 3, that's just 5. So instead of actually doing 2 times 15, you just go straight to say, oh, this is going to be 2 times 5, which is 10. Notice that whichever way you decide to do it, whether you reduce first or not, you end up with the same answer either way. In case you wanted to check your work at this point, you can always take the answer you get and plug it into the original problem. So over here on the side, I'm going to check the work. So I have 10 divided by 15, and that is equal to 2 over 3. Two ways you can find out. You can either reduce that fraction, 10 over 15. Both of them are divisible by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. Another way that you could have done it is if you were working with a calculator you would have seen that 10 divided by 15 gives you 0.66666 forever. That's what that bar means, that that number keeps going on forever. And 2 divided by 3 is also zero point 0.6 infinitely. So both of them have the same decimal value, so they are equal on both sides. I won't always be checking every single example problem as we work on it. I'll just leave it as the answer is 10, for example. But now you know how to check your work in case you wanted to go back and make sure that you got it right. Alright, next problem. So here we're told to solve n minus 2 over 7 equal to 10 divided by 35. So I notice that I do have a variable in the numerator, this time it's n, and it's only on one side of the equation. So I am going to use the multiplication property again. So since I want to get that n alone, what number should I multiply by? We're going to be multiplying by 7 on both sides, because that's the first step to getting the n alone. I know that minus 2 is still there, but we're using an inverse operation. I had divided by 7 on that page, so I had to multiply by 7 to get rid of it. So again, we only multiply the 7 with the numerator, so 10 times 7 is 70. And I'm left with n minus 2 equals 70 divided by 35. And what is 70 divided by 35? Well, that's 2. So now I have n minus 2 equals 2. And lastly, since I do want to isolate that n, right now I have a minus 2 attached to it. I have to use the inverse operation of subtraction, which is addition. So I have to add 2 on both sides to get my final answer that n equals 4. Once again, you can take that 4 and plug it in where you see n in the original equation, and both sides of the equal sign will have the same value. Alright, so we talked about that first method of the multiplication property. Now there's a second method. So method number 2. This is called the cross products property. Most likely you would have heard it as cross multiplying. So this most likely is not something new to you. And this is the official wording, mathematical jargon. The cross products of a proportion are equal, meaning if you have A over B equals C over D, they include that B not equal to 0 and D not equal to 0 just because you can't divide by 0. It's impossible. So they're just letting you know, make sure that the denominators aren't 0. Then A times D is equal to B times C. Notice that they just took the D from the bottom of one fraction and multiplied it with the A on top, and the B from the bottom of the other one and multiplied it with the C in the numerator on the right hand side. So once again, that's what you'd call cross multiplying. So we use this method when the unknown variable is in the denominator, so if it's in the bottom ever, or if we see it on both sides and not just on one side. So let's look at our first example problem. 12 over t is equal to 20 over 3. So I see that that t is in the denominator, so I do need to cross multiply. So that 3 needs to be multiplied with the 12 on the left, and then the t moves in with the 20 on the right. So 12 times 3 equals 20 times t. 12 times 3 is 36. Now I want to isolate that t. Right now that 20 and the t are being multiplied together, so I do have to divide the inverse operation of multiplication by 20. So technically a correct answer is 36 over 20. However, we do try and reduce when possible. For sure 36 and 20 are divisible by 2 because they're both even. But even more than that, they're divisible by 4. 36 divided by 4 is 9, and 20 divided by 4 is 5. So my simplified or reduced answer is t equals 9/5, or 9 over 5. You don't have to worry about putting it in decimal form. Fraction form, even though it's an improper fraction, is perfectly acceptable. Now let's look at a second example. So this one has solve n m minus 3 over 6 is equal to m plus 8 divided by 2. Here, the variables are not in the denominator, but the second criteria was if it's present on both sides. So notice there's an m on the left and there's an m on the right. So we do the same thing here. Now when we multiply, we do have to distribute or multiply that 2 with everything that's in the numerator on the left and the 6 with everything that's in the numerator on the right. If you only multiply by the first thing and not everything, then you will end up with an incorrect answer. So we have 2m minus 6 equals 6m plus 48. I subtract 2m from both sides. Remember in the last video I said it doesn't matter if you move it to the left or the right. Personally, I just like to keep things positive, so I moved it to the right. You would still get the same answer if you moved your variable to the left. So I'm left with negative 6 equals 4m plus 48. I want to slowly get that m alone. So first I have to detach that 48. Use the inverse operation of subtraction. Subtract 48 from both sides. Remember that when you're combining two things that are negative, it's even more negative. And what I tell people all the time is, if I'm a negative person and you're a negative person, then together we are just extremely negative. So negative 6 minus 48, we're an even more negative number of negative 54. And we still have that 4m on the right. In order to get rid of the 4, we do have to divide. So when we divide by both sides, I'm sorry it's getting kind of squished there, we see m equals negative 54 divided by 4. Once again, we can reduce. They're both even numbers, so they're divisible by 2. And our final answer is m equals negative 27 divided by 2. Most of the time, I prefer that my answers are left in fraction form. But if you wanted, you could also put down that m would be, let's see, negative 13.5. That's what negative 27 divided by 2 is. So this is a correct answer as well. All right. So now that we've learned both methods of solving proportions, how are we going to use them? So we use proportions to find missing side lengths in similar figures. So a similar figure or similar figures look like they're the same shape, but they're just different sizes. So imagine it's like you took one shape and then you zoomed into it so it got bigger. Looks the same, just a different size. So you'll see that little squiggly line, that symbol, it's called a tilde. That means similar to. And so we're going to be getting either the actual image, like a picture in the problem, or we might get a word problem. In order to solve these, we first have to create a proportion and then solve that proportion. Here's an example. So let's say we have these two rectangles, and we know for sure because we're told that rectangle ABCD is similar to rectangle WXYZ. I see that in the smaller rectangle I have actual values like 2 and 5, but on the larger one I actually don't have exact values. I have expressions like m plus 7 and 8m plus 1. So first we have to create our own proportion. One proportion that we can create is m plus 7 over 2 is equal to 8m plus 1 over 5. The way that we're able to do this is by comparing what is similar. So for example, I see that this m plus 7 is this left hand side of the rectangle, which corresponds to the 2 on the right hand side, the smaller rectangle. So that's why I have m plus 7 here over 2. Now I can also compare the upper end, 8m plus 1, with the top side of the smaller one of 5. So that's why I have 8m plus 1 here with the 5 down here. Now what matters is that The numerator should be from the same shape, and then the denominator should also be from the same shape. So you can't just kind of mix them up and put things wherever you want them. There is another way that you can set this up. So there's more than one way to do things. So I could have put the m plus 7 over 8m plus 1 and then equals 2 over 5 on the other side. Now, why could I have done this? Well, like I said, what matters is that there's actually like a relationship involved. So here I had right side over top, I guess you could say. Oh, I meant left, sorry. So I have the left side of the rectangle over the top side of the rectangle. And that's where I got this fraction here, this ratio. And then as long as I do it the exact same way, I took the 2 and I have the left hand side over the top, then that's okay. So pretty much you can take one shape or one of the figures and set it up however you want, but then you have to make sure that you set up the other side exactly the same way. Alright, but now let's actually continue to solve these. So now that we know how to set them up, it's just a matter of using one of the methods that we learned to actually solve. In this case, what method should we use? Well, on the left hand side, I see that I have the variable m on both sides. Even if I set it up the way I did on the right, well, I notice that there's an m in the denominator. So either way, the criteria says that I should use the cross products method. So let's go ahead and do that on the left hand side. I'm going to multiply 5 with m plus 7 and 2 with 8m plus 1. Remember to distribute, and I get 5m plus 35 equals 16m plus 2. And then I have to subtract 5m from both sides to try and get all my variables on one side. I end up with 35 equals 11m plus 2. I subtract 2 from both sides to get 33 equals 11m. And then I divide by 11 to see that m equals 3. And I've finished the problem. So if it had said solve for m, I'd be able to figure out that m was 3. Perhaps I didn't actually give a prompt here, but if sometimes the prompt actually asks for you to determine the side lengths, then you could take that m and plug it back in. So here, 3 plus 7, this side length would be 10. And then on the upper end, 8 times 3 is 24 plus 1, this side length would be 25. So if they actually ask for the length, then I just plug in what I figured out my answer was. I noticed that 10 over 25 is proportional to 2 over 5. Because you could take the 2, multiply it by 5 and get 10. You take the 5, multiply it by 5 and get 25. Alright, so what if you had set it up the second way? Well, we would use the cross products method and end up with 5 times m plus 7 equals 2 times 8m plus 1. And notice that that's exactly what we had on the left hand side. So you do the exact same algebra and end up with the same answer. The only difference is that first step, where we set it up, looked different, but ultimately you ended up doing the same operations. Alright, and here's our last problem for this video. I know this video is going on 20 minutes, my apologies, but this one did have a bit more information that I had to share. Still better than an hour worth of homework. Anyway, so the problem here says that Stacy is walking home and passes by a tall tree. She notices that the tree casts a shadow of 21 feet. Well, Stacy knows that she's 5 feet tall and that her own shadow is 4 feet long. So what is the height of the tree? How can we figure out how tall the tree is just with this information? So I'm a visual learner, so I like to have some sort of drawing. You would think because I'm visual that I'm good at drawing, but no, not at all. So please bear with me with these drawings that I have. So I know that I have a tree, and I know that there's a girl, Stacy, And I've put in a few labels here. I put H to represent the height of the tree. And I know that the tree shadow is 21 feet long. I know I have Stacy here that's 5 feet tall, and her shadow is 4 feet long. So since we've already talked about how to set up the proportions, maybe now is a good time to pause and set up one of the proportions, see if you can do it right. And now I'm going to actually show you the two possible proportions that you could have made out of this. So you could have either put h over 21, which is all from one triangle, and then set it equal to 5 over 4. Notice that we set the height of the object on both times over the length of the shadow both times. Again, as long as you set them up in the same way, you're good. Or perhaps you compared the two heights together first, h over 21, and then compared the two lengths of the shadows, equals 21 over 4. Notice that both the numerators come from the tree and both the denominators come from the person. So again, there's always two possible ways to set up a proportion. As long as you're consistent with how you set it up, it's okay. Now in this case, what method would we use to solve it? Well, I see that that h in both instances is in the numerator, and there's only one h on one side of the equation. So either way, we would be using the multiplication property. And when we use the multiplication property, you either multiply by 21 or by 5, but ultimately both sides have h equal 21 times 5 over 4, which 21 times 5 is 105 over 4. Now, this is a correct answer, and we cannot reduce this answer because there's no number that will divide 105 and 4. So, like I mentioned before, you can leave your answer like this and it's correct, but this doesn't give us a very good indication of how tall the tree actually is. So if you went ahead and actually divided 105 by 4, you'd see that that's 26.25 feet. So this tree was 26.25 feet tall. Alright, so those are all the notes that I have for you today. In class, you will be doing some practice on both word problems and image problems. So make sure that you take these notes with you so that way you can use them as you're working on the practice problems in class. Alright, bye-bye for now.